Some trig identities, or at least information to do with the trig. These three here are very often called the Pythagorean identities, just a name connected to Pythagoras. And you all know that one, but if you rearrange it, sine squared can be written like this, cos squared can be written like that. You can also call cos squared this guy and sine squared this guy. And you can also call the sine of 2 theta this guy. So these are basically versions of the double angle identities. And down here we have some identities that involve secants, secants, tangents, and secant squares and tangent squares. These two down here are quite useful for turning secants into tans, or sometimes you want to turn tans into secants. And this little guy down here is just a standard integral that you can kind of add to your list. You know how we know the integral of secant squared is tan? Because we know it is, we've been told it is. Well, the secant on its own, right, an integral secant, is the natural log of a secant plus a tan. And that's just a thing you memorize in the same way that you memorize that the integral of secant squared is tan. So far, so good. Don't hear any negatives, so I shall proceed. So we're going to look at various integrals that use trig functions. The most likely strategies that you're going to be using. There we go. The most likely strategies that you're going to be using. Sorry about this. Okay. Does that look horizontal to you? Because it looks like it's sloping to me. Oh, that helps. Worse. Oh, maybe it's something to do with the paper. Do you see how easy it is for me to distract myself? You know that? Okay, let's get back to what my thought process was. Right, so there are a couple of strategies that we're going to use to integrate trig functions. One is identities. In other words, you change the original integral using one of these things into something that we can actually integrate. The second major strategy you're going to use is u-subs. It's a pretty hefty strategy as well. And that's the two main ones. So let's start off with a very simple question that isn't as simple as it seems. Just a sine squared on its own. I mean, how hard could a sine squared on its own be? Well, surprisingly, yes, it can be. So how would I go about integrating that? Well, I would go hunting for an identity. Because I can't, let's rewind this. If you were thinking, oh, I'll just use the power rule, so it's going to be sine cubed with a third at the front, that isn't the power rule. The power rule is for theta squared or x squared. It's not for sine squared or anybody else squared. So you may have thought that, but that wouldn't work. So what we do is we'll look at this fella and we say, I can rewrite it using this identity here, which means that I can now distribute the half, at least that's how I would do it. And then I can integrate with respect to theta. Oops. 1/2 x. Right, if you, whoops, there we go again. If you do a cosine, its antiderivative is sine. If you do a cosine of 2 theta, don't you get a half of the sine of 2 theta? Remember the linear shortcut. And that's why this is a quarter. And why it still remains a negative. Are we happy about that integral now? So 2 theta or half theta, take away quarter, the sine, 2 theta plus arbitrary constant gives you that. We got, we good? Got any comments about that, or can I move on? Okay. So right now we're looking at single powers of sine or cosine. I could do a similar thing with cosines. We looked at how you deal with a square. Let's look at how you would deal with a cube. Any suggestions on what I could do here?
Could you wait,
Yeah, what was it?
could you split it to be like sine squared theta and then just times it by sine?
Yeah, you could, and that's exactly what you should do. Now we have to do a little bit more. That's the correct thing to do. Is there a different form of sine squared? Well, yeah. I could do this one, but can you trust me, this one leads you down a blind end, right? I could, of course, use this one. Now, we started off with this, and now we're here, and you might think, this is just getting worse. This is not helping. Actually, it is helping. You just have to go with the flow and keep going. Now, at this point here, what do you think I should do next?
U sub?
And that sounds like a good idea. What would the U sub be?
Cosine?
Well done. Right. You want to, that's the correct answer. Sometimes students say it better than I could. What made you think of the cosine?
Because I can get rid of the factor of sine.
Yep. So, bad planning by me, so I'll do it over here. The U sub is only the cosine. Have you noticed that when you do these U subs, and I'm sure I mentioned it yesterday, isn't it always a single sine or a single cosine? You never do a U sub of cos squared or a U sub of sine squared. Typically, that doesn't work, right? So cosine on its own looks good. Now, if you differentiate this with respect to theta, you get a negative sign. You then do the crossover. And then you isolate. So it's now time for me to go over here. And what do we have? We have sine theta, a 1 minus u squared, a negative 1 over sine theta, du. And just like you said, do you see the signs cancelling out? Oh God, there's a funny negative here, isn't there? So maybe I should just multiply through by negative 1 to take care of that. And negative 1 times this, and negative 1 times this. Would you agree that we're getting there, aren't we? We've at least got to a place where we can now integrate. This fella is negative u, and by the power rule, this is 1/3 cubed. So we now got to there. Where are we off to next? Just one thing to do and we're finished. Where are we off to next?
You plug in u.
Right, and every u turns into a cosine. Bingo, you got it.
Professor, is it all right to leave the negative out and then after you do all your U subs, then times it by the negative? Is that okay too?
Yep, totally okay.
Okay.
Now, I haven't done cos squared theta or cos cubed theta, but can you imagine those two would be virtually the same methods? You agree? Cos squared, sine squared, cos cubed, sine cubed, right? Same kind of algebra, right? Same, similar kind of results. Right. Now we're going to look at combinations of sines and cosines. How about all the questions I'm doing, I am leaving out the limits integration. Quite a lot of the questions are from 0 to pi, from 0 to pi upon 2. And all that would be is that you'd remove this guy, wouldn't you? You plug in pi, you plug in 0, and you get 4/3 or whatever the answer is. I'm just leaving that bit out because it takes time and I'm sure you can deal with it. Okay, let's try the integral of the sine of this guy times the cosine of this guy. So we're going to look at combinations of sines and cosines, powers of sines and cosines. So that's where we are right now. In this world, you do not need to use trig identities yet. That will happen a little bit later. But right now, I don't need to do any trig identities. What I do need to do is figure out which U sub I should use. Sine theta, cosine theta, or it probably doesn't matter. In other words, pick either one. What do you think?
Either one.
Yeah, either one will do. Sine 5, cosine 5. Can pick either one. In this situation, because the powers are the same, it's just going to be as ugly no matter which one you do. So I'm going to tell you what I would pick. I'm going to pick that one. And it's a very minor reason, but I'm still picking it. Could anybody get into my thought process why I chose the sine theta one instead of the cosine?
It wouldn't make a negative.
Yeah. And you know me and careless, right? So if you can avoid careless, isn't it just a good idea? So that's a very minor reason. I wouldn't be too concerned if you didn't think that was an important reason. Now, when you do a combination of powers of sines and cosines, your first step will be this: pick a U sub. In this case, it didn't matter. Later on, I'm going to show you a situation where it does matter. But right now, sine or cosine doesn't really matter. So what do we have? Well, we have an integral of u to the 5 cosine powers, a 1 over cosine du. And after a tidying up, a very minor tidying up, I'm left with that. Now identities kick in. That ain't any good. That's got to go away. It's got to go away and be turned into something with use. In other words, it's got to be turned into things with sines. The 4th power of cosine is not in my list, nor should it be, because if I did that, this would be about 10 pieces of paper. So we just adapt what we see here. This is the guy I'm going to use. Cos squared can be written as 1 minus sine squared. And I adapt it to this situation. Isn't cosine to the power of 4 the same thing as cos squared squared? Do you agree? Now, normally I wouldn't write this line, but since this is notes, I will. Right? Would you agree that is that? Now, can you see why the line that I'm pointing at can now be useful? Because we now have that. And why is that useful? Well, that's useful because u is sine theta. So this guy ends up being that guy. So far, so good. Okay, where are we going next? It's nothing to do with trig, but what do we do next?
Distribute.
Okay. You get a 1 take away 2u squared plus a u to the 4 du. That gets me u to the 5. That gets me 2 u to the 7s. And that gets me u to the 9 du. Is it all looking good? Right. Don't we just go right into the power rule? Add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and one more of them. In my case, I'm doing a plus C. And then convert back. To thetas. I mean, there's probably a good 3 or 4 lines there that you could probably do in your head and not actually write down. But do you get the flow of how this question worked? Right, it had a kind of a logical progression from start to finish. So a U sub gets me to here. I then work on this guy to get it into U's, and then do a bit of algebra, power rule, and convert back. The only difference would be if this was 0 to pi, then wouldn't that there disappear and you do theta equals 0 to equals pi and subtract your two answers, which in this case it would be 0 probably. What do you think would have happened if I'd started with cosine theta as my U? Do you think my answer would look like this or would it look different?
It would probably have all the negatives, so you would probably have maybe a negative
Neg
1.6 and then a plus
Oh, so the
1.4.
constants might be different, yeah. Do you think it'd still be in terms of sine theta, or do you think the final answer would be in terms of cosine theta? If you did a U sub at the beginning, yeah. So you could be right about the plus and minuses. I wouldn't be surprised if that was true. But what's more important is that these are all cosines. So a word of warning here, and it's not that you've done anything wrong, just want to warn you about it. Can you imagine that WebAssign had this in its answer bank, but it didn't have the cosine version? Do you see how you could be marked as wrong when you're really right? What you've got is a different version of right. That's annoying about trig, that when you do things with x cubes and x squareds and stuff, isn't there only one final answer and you all end up at the same destination? But in trig, because of identities and the way that you can sometimes pick a different U sub and still get an answer, you could have various versions of the correct answer that don't necessarily even look very similar. If you come across a question where you are really sure that you did it right, but WebAssign kept on giving you a big X, if you shoot me the answer, I'll have a look, and if you are correct, I'll fix the homework grade for you. Right, I just go in and I give you bonus points. We go. Now, a second thing that may or may not be true. If you want to write this in, you may have to put a bracket around it, do a sine theta, close the bracket, and 6. Because I'm not sure that WebAssign can handle it written the way that we write it down in paper. In other words, sine little 6 theta. I think you may have to call it sine theta, big brackets around it 6.
It lets you do that.
It will allow this?
Yeah.
Oh, okay. Then ignore that last statement because it doesn't matter. Are we good? Right, so let's try another combination of sines and cosines. How about this fella? Now, the only thing I did was make this 3 instead of 5. And the question becomes, which u sub? Now, when we're both 5, it was an equal amount of work, so it really didn't matter which you pick. In this situation, it does matter in the sense that one u sub will give you very little work, and the other u sub will give you a heck of a lot more work. So based on the fact that we want to do the least amount of work possible, what would be the best u sub for this story?
Cosine.
You want to tell us why you went that way, which is the right one?
Because once we find the derivative of cosine, it'll make the sine cubed into sine squared, and we can use one of our trig identities to get like 1/2 1 minus
Right.
cosine 2 theta.
Well, no. Everything great until that last bit. No, just turn it into one of these. Just use that one. So everything up to that last part was pretty much what I hope you'd say. Let's take it through the process. I'll show you what I was talking about. Okay, so we're here. Just like you said, you're going to use up one of these in a minute. That fella becomes a very nice u to the 5. And this fella becomes -1 over sine theta du. And just like you said, right up to there, we are both in agreement. I'll stick a little negative here. But I'm not going to turn that guy into this fella. I'm going to turn that guy into this fella. There we go. Which means that fella. Can you see why that is going to work better? Because now everything is in terms of cosine. And then distribute. And then do all the usual stuff. Now, what would have happened if I'd chosen sine theta? Well, one of these cosines would have been used up. I'd be left with a cosine 4, and a cosine 4 looks like this guy here, which means it's more work. But if this guy here was 15, do you see it was even more important that you chose the cosine? Because you do not want to do the other way around, because you end up having to do a 1 minus u squared to the power of 7, and good luck with that. Now, how about a combination of even and odd? So, by the way, the rule for this one, if they're both odd, use the bigger one as your u sub. So if one of them's a cube and the other one's a 7, whatever trig function is the 7th power, make that your u sub. So if it says cosine to the 7th power of theta, then you would use the cosine. Now, how about an even odd? That is also a u sub. And we have a choice again, sine or cosine. Now this time, even if you choose the wrong one, it just won't work. At least in the two examples I gave earlier, theoretically at least, it would work. One of them might take a lot longer to do, but eventually it would work. But in this case, nah. In this case, only one of those two is the right one. Which is the use of sine or cosine?
Sine.
Fine.
I like the fact lots of you are joining in on that one. Did you notice why the sine is the good one and not the cosine?
Because you can make cosine cubed into cosine squared.
And turn it into one of these after the event. Exactly. So I just realized something. I shouldn't be writing this all the time. Since it's sine and cosine, couldn't I just go right to the end? Because it's the same blinking 4 lines every time, isn't it? What is d theta going to be when I'm finished there?
1 over cosine theta du.
You know, if you do a lot of these, aren't you probably just going to do that anyway? You know, oh, okay. I know how to do a U sub when it's sine theta. You always end up with this. So you can fill in that missing line if you want. So we have that fella. Oh, no, we don't. We have that fella. Cosine cubed. It's like you were saying, a 1 over cosine. And a du. That gets me cos squared. And the cos squared turns into this guy. 1 minus sine squared, right? I've just skipped a line. Are you happy how cos squared turned into that, or do you need to see this line in the middle? Is cos squared becoming 1 minus u squared? Does that seem easy to understand? Right. If you distribute, at this point, can I just do another dot, dot, dot? It doesn't have the familiar finish that many of these questions have. Power row, convert back to sine thetas. We good? Right. So let me get something that's bugging me. James, sine theta. Say that to me. Just say sine theta.
Sine theta.
Do you know people say theta in America? Do you know I say theta? Have you detected that there's a difference?
I mean, there's a slight difference.
Yeah. Why can't Americans speak proper? It's theta. It's a hard E. It's not theta, a gentle E, right? It's a masculine variable. It's a theta, right? It's a theta, not theta. Damn, that annoys me.
I reckon we just can't help ourselves.
Yes, I've noticed that. I understand, well, maybe not understand's the right word, but I know why you may have changed Z to Z and a few other letters. That's because you couldn't pronounce things. I understand that could happen. But how could you screw up a totally different country's letters?
I mean, we
Okay.
also removed the E from a lot of the ends of words, so.
Yeah, you're just weird, aren't you?
Pronunciation in English is confusing
What's
because
that?
there's no accents.
My wife just joined in the background. She said, how did you screw up our letters? Oh, they're going to be a family argument, and I can tell. I do love you, but you drive me crazy sometimes as a country. You certainly do. I don't know how you do things, but God, you can screw them up sometimes. Okay, so if I give you a combination of 2 odd powers of sine and cosine, you feel comfortable about the use of. If I give you an odd and an even pair, you're comfortable about the use of. So essentially, isn't there only one combination I haven't done yet? And that's
Both
an even.
evens.
Both even. So we need to see how that's going to work. This is actually question 7, or at least a version of it. Oh, let's put X's in. Stick a 4 there. And I'm being a little bit unfair here. What do you do next? Have you noticed that U subs don't work? So it was a bit unfair putting this box there because it made you think there was a U sub coming. Now you might say, yeah, a U sub could work. No, sorry, it won't. If you make U sine theta, sine X, won't you only eat one of these up and you'll be left with cosine X on its own? And trust me, that is not going to end well. You'll never get rid of a single cosine. You can get rid of sine squares and cos squares, right? But if you try and get rid of a single one, it just ends up being some weird square root thing that never goes anywhere.
So we use the identity.
Yeah. So somewhere in this list on the left-hand side, there's one particular identity that is going to be used to make this fella doable.
Would it be the sine 2 theta?
Okay. Yes, it is. Do you want to take it a bit further?
But then would we have to square it? So sine 2 theta square, or square all of it?
Oh, yeah. Okay. So is this guy that guy?
Yes.
Yeah. And who is this guy?
That is
Sine squared theta.
Mm-mm.
sine 2 theta.
Yeah.
Oh, sorry.
Yeah. And I don't know why I did it that way, but it's too late now. Oh. So you've turned this ugly guy into a different ugly guy. Good idea? Still go with it. Now we have to do something that I don't know if you've ever done before. We are going to use this identity here. And you're going to say, wait a minute, this identity here has a theta, and this thing has a 2x. How can this be used here? Well, I want you to think of sine squared theta, which in this case is 1 minus the cosine of 2 theta. And I don't want you to think of that so much as a theta, but a placeholder where you put things. So if you use this as your template, then sine squared 2x becomes a half 1 minus the cosine of how many x?
4x.
So do you see that you can adapt this formula to make that happen? Which means we now have 1/2 1 minus the cosine of 4x, which then becomes 1/2 take away 1/2 cosine of 4x. And that can be integrated. That is a half, gets you half x. A cosine, when you integrate it, gives you a sine. The 4 gets you another quarter. So you get negative 1/8 the sine of 4x. Add C. So this question was really done by, what's the word I'm looking for? By identities, repeated use of 2 different identities, essentially.
Professor,
Yes.
isn't it plus 1/8 sine 4x?
Yeah.
Yeah.
If you do an antiderivative of a cosine, you get a positive sign, so it stays negative because of that.
Oh, okay.
What happens to that 4 at the beginning?
That 4 here became a quarter, and a quarter and a half became an eighth.
Oh, like at the beginning of the problem?
What happened to that 4? What's 2 squared?
4.
That's what
Okay,
I'm
I see, I see. Thank you.
We good? So, I mean, there are other versions of even, but they are so ugly, you're not going to see them. I could do a sine 6 and a cosine 8. That would take me about a day to do because the math in that would be so horrendously ugly. I'd be there all day trying to do it. So don't worry about things that are not going to appear. But there's an even. Now, I guess I could have made this a little bit harder. Suppose that 4 was 10. That's going to make this a little bit trickier, isn't it?
Mm-hmm.
So what you would probably do here is think of it as 10 sine x, cosine x, right? The squared, guys. Well, let's do it again. Imagine it was 10 sine squared, cos squared. All I'm doing is a little different approach to it. I'm going to take that and think of it as sine x, cosine x, just being squared. It doesn't have the 2, right? Which means that when I use my identity here, won't this become a half the sine of 2x? If 2 sine x cosine x is the sine of 2x, a single sine x cosine x will be half of the sine of 2x. And that's how I would tackle that. Then when you FOIL it out, you get 10, and that's 4. 10 over 4 gets me 5 halves. And that would be the difference. Right. And the one that we did, I mean, 4 matched perfectly for what you needed. But in general, that number's not going to be a perfect match. So that's the workaround. Just suck out the sine and cosine on its own and replace it by a half. And then when you square it out, you're back to where you should be. Now that guy then gets replaced by this fella. And off you go and you do what you need to do.
Professor,
Yes.
I had a question about the answer of this problem we just did.
Yes.
So for the cosine, when you took the integral of cosine, shouldn't it be positive sign?
Yes. And it is.
But isn't there a negative sign there?
Yeah,
for the
because
answer?
there's a negative here.
But isn't it like negative cosine you're taking the integral?
Okay, so if you take the
Wait.
integral of a negative cosine, you get a negative sign.
Sorry, I keep on getting the directions mixed up.
I know, it's so easy, isn't it? It's because when you differentiate, the sign goes one way, and you integrate, the sign doesn't, and you're forever juggling signs. It's a common mistake. There we go.
Thank you.
Okay. I think that's all the permutations of sines and cosines. Oh, no, there isn't. There's one more. It's not really different from what we've done. Is just an added complication, really. It might not always be x. Can you imagine it might be sine cubed 3x, cos squared 3x. The x's are going to be the same, right? It only requires a minor adaptation. What would the u sub in this question be?
Cosine 4x?
So that when you do your differentiation, you're going to get negative the sine of 4x. Oh, and a 4, so it's negative 4. And then you're going to get negative 4 the sine of 4x dx. And then that's going to come out as this fella. So do you see, basically you just get an extra 4 or quarter floating about. Let's see how that affects things. Sine cubed 4x is still good right now. That's going to be a u squared. That's going to be negative 1 over 4 sine 4x. There's a dx. Not dx, sorry. Du. Okay. One of these cancels one of these. I'm now going to have negative 1/4 u squared. And I have a sine squared of 4x left over. Okay. Don't let that 4x throw you. Think of it as theta. Can't sine squared 4x be written as 1 take away cos squared 4x? So what we have here, and I'll put this line in, which means that it's basically just that. If you go back and look at a question where these are x's, won't they almost the math look exactly the same? And you just distribute. And then, you know, dot, 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 right? Do what you need to do. Are we okay with that? It's just a nuance, isn't it? It's really the same as we're doing. But they're going to stick a 3x and a 3x or a 10x and a 10x. But pretty much do what you would have done if it was simply just x in both cases.
Professor,
Yes.
what would happen if we had like two even powers and we had the like a 4x? So like sine sine to the 4th power 4x and then cosine squared 4x.
Like that?
Yeah.
Well, firstly, you're not going to get that one, but if you did get that one, you would have to split these two guys up. And you'd have to use this version here. So this fella would become 1/2, 1 plus the cosine of 8x. This fella would be 1/2, 1 minus the cosine. Do you notice that the x's have doubled up?
Mm-hmm.
And it would be squared. And then you would FOIL all of that out, and you'd get various versions of 8x and cos 8x squared. You would then, for the cos squared ones, apply this, and you get some cosine 18x's, and that would be about 20 minutes later. And then you could integrate the whole thing, and that's probably why you don't get that question. But that's,
Okay.
that's what you would have done. Okay. Now, let's mix and match. Tans. Cosines. So we've done every kind of combination of sines and cosines, but let's do tans and cosines, or secants and cosines, right? Something from this batch mixing up with something with this batch. And in those cases, you have to do a conversion. In other words, you have to change this question from what it looks like into something that we can deal with. Is there anything that you can see in this list that you can change into something else that might help this process move along?
Change the tan to sine over cosine.
So I'm going to use this one. And this guy becomes that fella over this fella times that fella. What's going to happen now?
Gonna cross out the cosines.
And one's going to be left over, right? Now, do you recognize that guy as a guy that we've done today? Isn't this a u sub? Just make sure you pick the right one and you're good to go. What is the correct use sub in this question?
Fine.
Agreed. And ... right? Oh, will you all say hi for attendance? Oops. We have really covered quite a lot of permutations today. And hopefully I've not overwhelmed you too much. And have you noticed that you only really get one shot of each kind? So it's not like you got like 8 practiced ones, so you're really good at it. You get like one shot of something and then they go and change. You know, the next question, they go and change something and you have to do a different technique or a different use of or a different something. So a lot of different things that you have to kind of juggle in the air. Yeah, I wish that